Welcome to today's lecture. Today we'll be looking at transformer. And this is part 1. What is a transformer? A transformer is a device that is used for changing the voltage of an AC supply. So let's see. A transformer is a device used for changing the voltage of an AC supply. It is an electrical device used to increase or decrease alternating current voltage without changing the frequency. That is, a transformer is used to increase the voltage of an AC supply or to decrease the voltage of an AC supply without tampering with the frequency of the AC current. That is alternating current, I beg your pardon, without tampering with the frequency of the AC. I want you to note that a transformer works only with alternating current and not with direct current. What then is the principle of operation? This is a schematic view of a transformer. You have the soft iron core. You have the coil wound on the primary side of the soft iron core, and this is connected to an alternating current. Then you have the secondary side and the secondary coil wound on the secondary part of the soft iron core, and this part is always connected to the load. So this is the mains, this is the load. The primary side is associated with the mains, that is the supply of the alternating current, while the secondary side is connected to the load. A transformer works on the principle of mutual inductance, or what we call mutual electromagnetic induction. Now let's see the principle. What's the mode of operation? The principle: when an alternating current flows through the primary coil, it produces a changing magnetic flux, magnetic lines of force, magnetic field lines in the soft iron core. This changing flux links the secondary coil by mutual inductance, thereby inducing an EMF in it. So this is a brief way of describing the principle of operation of a transformer. What are the essential parts of a transformer? Number 1, the primary coil, which is connected to an AC source. Number 2, the secondary coil, connected to the load. Number 3, the soft iron core, which provides a path for magnetic flux, magnetic lines of force. The soft iron core consists of thin sheets of soft iron, laminated and insulated from one another. Let's see the key points. The soft iron core is made of soft iron. Number 2, is arranged in thin laminated sheets. The sheets are insulated from each other. Why is it so? Why is this structure? The soft ion is easily magnetized and demagnetized. That is why soft ion is used. It is easily magnetized and demagnetized, and this reduces the problem of hysteresis loss that we will look at later. Number two, lamination reduces eddy current losses. In other words, the soft ion is easy to laminate, and the lamination reduces eddy current losses. Number three, insulation between the sheets prevents large circulating current. The large circulating current is what we refer to as eddy current. Eddy current. This will take us to types of transformer. We have basically two types of transformer. Number one, we have the step-up transformer. In the step-up transformer, the number of turns, these are called turns, okay? These are called turns. So in the step-up transformer, the number of turns in the secondary coil is greater than the number of turns in the primary coil. Okay, so if you're going to draw a step-up transformer, you must make sure that the number of turns in the secondary coil, secondary part of the transformer, is greater than the number of turns in the primary side of the transformer. So this setup increases the voltage, the output voltage. The secondary turns are greater than the primary turns. I'm supposed to put than here. So the secondary turns are greater than the primary turns. That is, the number of turns in the secondary coil is greater than that of the primary coil. It is used in power transmission. This type of transformer cannot be used in home appliances. It can only be used in power transmission. So a summary of what we have just said now: the number of turns in the primary coil is greater than the number of turns in the secondary coil is greater than the number of turns in the primary coil. The voltage, that is the EMF in the secondary coil, is greater than the EMF in the primary coil. Now let's look at the meaning of the symbols used. NS, a number of turns in the secondary coil. NP, number of turns in the primary coil. EAS, which is also called VAS, EMF of the secondary coil, of voltage in the secondary coil. AP or VP, EMF of the primary coil, of voltage in the primary coil. Number two is step-down transformer. Now if you notice, the number of turns in the primary side is greater than the number of turns in the secondary side. So it means you are stepping down the voltage. By this connection and by this arrangement, the voltage decreases. The number of turns in the primary coil is greater than the number of turns in the secondary coil. This type of transformer, that is the step-down transformer, is used in homes and electronic devices. So we can say that the number of turns in the secondary coil, NS, is less than the number of turns in the primary coil, NP. That is, NP is greater than NS. The EMF, that is the voltage in the secondary coil, is less than the voltage in the primary coil. transformer equation, ES over EP is NS over NP is IP over IS. You need to commit this formula to memory. This is the major formula referred to as the transformer equation. IP here means current in the primary coil. IS current in the secondary coil. NS over NP is referred to as turns ratio, not ration, it's ratio. So ignore the N, ignore this N. Turns ratio. If the turns ratio is greater than 1, then it is a step-up transformer. If the turns ratio is less than 1, that's a step-down transformer. If the turns ratio is equal to 1, then we refer to that as an isolation transformer. In our next lecture, we'll be looking at the meaning of what an isolation transformer is. I'll see you in part 2.